we're going to go over KubeWeekly newsletter. If you don't subscribe to it, it's really good. Check it out. It's really good. Appreciate these people for doing it. And we're just going to go over it today. It comes out every week. We could do this anytime we wanted, but we've done it once before. It's just chill. I think we enjoy doing kind of the hands-on stuff more. But today we are going to just chill and read through those notes. I am going to switch over to that screen right now. All right.
Yeah. I mean, we thought about starting the whole podcast around this because there's so much good content. I get it. I think it comes out on Friday. And by Friday, I'm like, I don't want to look at this stuff anymore. I just want to relax. So I always just leave it in my inbox. And then it was there on Monday when we were figuring out what we were going to do on stream. And today I'm like, you know what? We like to use this stream to learn in public and practice that skill. And like, when else am I going to do it? Might as well do it on stream. And we've been having some really good conversations with, I think, people that are newer to Kubernetes. And there was a couple really good articles that stuck out to me. Things that Makita and I went through, and Sam went through back when we did our CKA. Just some foundational things that reviewing them or just reviewing them feels good. And they're really important things. So, I think on the CKA
topic, so Devs Operative is a Kubernetes service provider. It's a certification that we've earned and pay for. And I recently got an email saying that, hey, don't forget that you have to have at least 3 people that are certified to keep your thing. And we're fine. But when I saw the email, I was like, oh man, I am not looking forward to having to take that test again. So it's not bad. I highly encourage people to take it. But when you do and you pass it, it is an accomplishment in my mind. Because if you look back at it and even if you're good at Kubernetes, it's still like a test. It's still like, it's just a lot. So kudos to everyone that passes it. And you should definitely feel proud of that certification if you have it.
I felt so good. I passed mine. CKS is get at me as well, but yeah, it's good. It's a great foundation, and that you can definitely build upon it and go anywhere with it. But anyway, shall we? Oh, look, marketing, BOGO. Okay, whatever. We're not doing that. You can see that yourself. You can do all this, blah, blah, blah. We're going to go down to the good stuff. So, right, those very fine people, they scrape the internet so that we don't have to follow all the accounts, and they put these really nice articles right here. And the one that jumped out to me is by Robusta, which is very interesting. I don't know what Robusta is. Should we see? Oh, it's coffee. Fine. Ultimate guide to a Kubernetes service versus a load balancer versus ingress. And when I was getting this, tripped me up for the longest time. And so I don't know, we'll take a peek at this. I reviewed it a little bit, but we'll just go through it. And I think it'll be good.
I'm curious what
people.
I don't know. I read that title and I feel like it's a little misleading, to be honest. Well, just because there is no such thing as a load balancer unless it's like a separate CRD.
They are talking, I think we'll get into it. It's a little misleading if you know what you're looking for. But I think it's aimed at people that don't know what they're doing yet, or that don't know the intricacies of this. And it's mostly about different types of Kubernetes services versus ingress is really what it boils down to. I think that's what you're trying to imply.
That is what I'm trying to imply. Yeah. A load balancer is a type of service. So to say a Kubernetes service versus a load balancer is one and the same. So they could say a cluster IP versus a load balancer. But let's go ahead. Sorry, just had to.
No problem. So there's that one. And then there's this one. How to handle Kubernetes health checks. And these stand out to me because I'm spending a lot of time dealing with ingress. and I'm spending a lot of time looking at things where their health checks and stuff aren't working. So those just kind of jumped out to me as like interesting.
The second from the bottom looks interesting too.
I know.
Because I've run into that, especially with our personal cluster, where we're installing all of the all the rancher stuff. We're installing, and they all are done with CRDs. So we just have hundreds of CRDs now. And if I ever have to uninstall it, it's hard.
Scary. Do you think they mean thousands of definitions or thousands of instances of CRDs?
I don't know, because people use it interchangeably, but
do they still
the way I read it is, that says scaling Kubernetes to thousands of custom resource definitions. So, the CRD is the definition. So if they're saying, how do you install 1,000 CRDs? Because otherwise I would, I don't know.
I know, right? Can we figure this out, people? Somebody write an article to just maybe we're the ones that are supposed to do that. We'll be having our blog coming out soon enough. That's a great stream topic. We could put this to bed. We could say, look, you're saying CRD wrong. There are two things. There's the definition, and then there's using the thing. Here's the word that we're going to use for the using the thing. The CRD is the definition. We need to invent some other one, or we gotta, I don't know, that or we're not doing it right. We gotta read the internet more. Maybe there's a better definition of this. Anyway,
ZK Win, just are you watching the chat?
Boom. Hey Zach, I've seen the API server get slow.
Which kind of I could totally see that happening. I haven't really dug into the implementation of CRDs. I wonder if they utilize the API extension server thing.
Yeah.
I don't know. But I could totally see that getting slow.
Yeah.
Because CRDs show up as a object type. So, the more things that you can fetch from the API server.
Yeah. Or if there's any call that's scraping metadata from all APIs or looking for something specific. There you go. If Sam were here, he'd probably want to talk about this. He loves this stuff. Actually, maybe he doesn't. Maybe he does.
He loves Spiffy. I would.
He loves Spiffy.
Whenever I go to a talk about it, I just don't know enough, but it sounds cool.
Sounds cool. I know. Okay.
All right. Are we going to jump into any of those things, or are we just going through?
Yeah, let's look at the rest of this. They're just pimping ArgoCon.
Oh my God, there's an ArgoCon? Has Argo gotten that popular already? Wow.
They're trying.
Impressive.
I like this too. Explain like I'm 5 open telemetry. Seems like that's pretty funny. Anyway. Oh, maybe this was up here. Is this a different list? The editorial.
Ooh, look at that.
Aqua Security's
Trivy adds CSPM capabilities. I don't know what that stands for. But we love Trivy. And if they're adding more functionality, that's cool. We should look at that one too.
I love her name. All right. Yeah, let's dig into this. Let's start with this health check one.
You got to make that bigger. Yeah.
Yep.
DoorDash.
First time. It's from DoorDash. Andres. How do you want to go over this? You want to read it? Or do you want to just jump around?
Normally I would skim it, but it's written like a book, so I don't know. Despite widespread adoption, Kubernetes probes are rarely fully understood, which can cause unintentional outages if internal understanding of their functionality is insufficient. even though deep technical understanding is often limited, there is a broad familiarity across the industry with readiness, liveness, and startup probes for containers. Most of the industry is using these widely across their organizations. Okay.
I mean, we can park right here.
I agree.
I have thoughts.
I mean, I have thoughts on this too already. Can I go first? Just some of the things that jump to my mind when I'm reading this is I agree with it. At face value, it's right. Like, I feel like the functionality of health checks and liveness probes in Kubernetes is like one of its main selling points for someone that's new to the system, and they immediately take advantage of it. What I think gets missed, and even in large organizations, like some of the big clients that we deal with, even if you set up the health check and liveness probe in the Kubernetes object, it still has to like point to something meaningful. And that endpoint that you point to, that /health, if you're not using something like Spring Boot, or there's some Go libraries that do it. I mean, every language has a set of libraries that has a standard set of health checking for whatever application server you're baking in or whatever. But even from that, like, you have to look at your app and say, what do I constitute as this app being healthy? You can even do some like downstream checks on like a database if you wanted to go that far. I know there's some like back and forth, schools of thought on going that far, but if your health check doesn't actually indicate the health of your app, then setting it in the Kubernetes object also means nothing. There you go. That's all I had.
No, that's exactly where I was at too. I did mostly read this article, or I skimmed it pretty hard, and I think you're going to be. It's not going to surprise you too much.
Zach basically reiterated the same thing just now. His first team didn't understand the readiness probes, right, and it caused an outage. Totally. Yeah. Like, understanding the difference between the liveness and the readiness is also important.
Yes. Let's see. The Kubernetes community did a particularly good job in marketing these probes. They exist in almost every open source application running on K8s and any templates or samples found on the wild internet. As a result, these probes have been viewed as health checks and have been widely adopted without the majority of users having a good understanding of what they're actually doing under the hood. Health checks. Oh my gosh. When you see health checks in quotes in this context, yeah, you go, damn. Guilty. I mean, I say it because it is. I mean, that's just kind of how people think about it. But then it's kind of a good reminder to be like, yeah. Readiness, liveness. Think about it.
This just kills me, dude. I think back to our first foray into enterprise Kubernetes, when we approached it, as application developers, we nailed our implementation. And the way we thought about it and the way we approached it, oh my God. Because like, now that we're doing Kubernetes professionally and we're working with other clients, I'm like, what? Like, how did we get it so right on our first try is beyond me.
I mean, yeah, we definitely got real close to the bullseye. We were on the dartboard. And I mean, we had to tune stuff over time a little bit, but they were small tunes. Yeah. I don't know. Probably because we used industry standard tools.
That's true. We got a lot for free from, Spring and stuff like that.
It's like follow the internet to a small degree, or a large degree, really. DoorDash, no exception. Robust adoption of K8s. In the last 1.5 years, we've incorporated these health checks. I didn't know. I mean, how old is DoorDash? I mean, they're pre-pandemic old.
Yeah, they were around. What? They got to be at least what? Maybe 10 years old.
Is it really? Dang. Supposedly, I have this for free on my credit card, since we have the same credit card. Same credit card company.
2013, so 9 years old.
Wow. But last 1.5 years, they've done Kubernetes implementation. Huh. Interesting. We've incorporated health checks into almost every single application without giving much thought to whether we needed those probes and what the health check endpoint used in the application does under the hood. You know, sounds honest. This is a pretty nice article. After a particularly bad outage on Black Friday, we learned that health checks could cause serious problems if not implemented correctly. What? Why is DoorDash busy on Black Friday? What's that got to do with it?
People don't want to leave the house.
I thought everybody likes to leave the house on Black Friday. Cyber Monday.
People want to spend money. You know, I bet you anything DoorDash has Black Friday deals.
It's a doorbuster. God, I hate that word, by the way. Fun fact. Anyway, which is why we decided to share our knowledge with the community in this post. Well, first, we will talk about the outage in question and how things went wrong. And then we will share the actionable steps we took to prevent this kind of problem in the future.
So this is a white paper, kind of.
I feel like they did a post-mortem and then they're like, hey, Andres,
can you publish this?
Put it on the internet. Can you publish this? Or he was like, hey, can I just get this out of the way? It's a nice read. It doesn't go too deep.
You should send this to our friend that you were working with today that did the health checks.
Potentially. It's on the consideration list. Because the DoorDash team lacked deep technical understanding of the health checks we were running, we experienced an informative incident on Black Friday. Aren't they all? Typically, busy holiday for DoorDash. Closer to the end of the day, our engineers received various alerts that our Tier 0 service was experiencing issues. Specifically, we saw CPU utilization spiking, increased response latencies, SLOs were burning. Let me come back to this. Reports were coming in from other services with failing dependencies. Service level O's?
Objective.
Service level objectives. This is a Dynatrace blog. Perfect. All right. Service level objectives. Let's just learn really quickly. Yeah, I've heard of SLA. I've heard of the agreements, contract between vendor and customer, or just soft, slows. Well, if Gartner came up with it, I mean, obviously, let's go. Agreed upon target within an SLA. Okay, it's a subset of the SLA. That must be achieved for each activity, function, and process to provide the best opportunity for customer success. Okay. The SLOs represent the performance or health of a service. Fair enough.
And what's the SLI?
It's a service level objective. What? SLIs provide the actual metrics. What is it even?
Is it service level indicator?
Where's the I?
Yeah.
Does it even say? Come on.
Okay. I was digging into
objective.
Tecton, which is kind of like a wrapper. It can be used as a wrapper around Argo, right? But they have this entire YAML framework where you're supposed to write out your SLOs in YAML. And I'll tell you, I went pretty far with it and everything, and the entire time I had no idea what SLO stood for. Just it's a metric of some kind. Let's go.
I mean, when I read it in context, I understand what they're trying to say here, but I wanted to understand that. Zach, big brain, knows what it is already. Very, very good. Okay. Our incident management tooling allowed us to quickly assemble the incident response team. How's bragging camp going? Okay. They got everybody together. Approximate diagnosis and time lapse. I don't know if time lapse is the right word. They had a large amount of pods failing the readiness probes being removed from the Kubernetes service. Not good. That is not good. The remaining pods were quickly overwhelmed by being forced to handle majority of requests, skyrocketing their CPU. Yeah. So when the readiness probe fails, Kubernetes says, I will no longer send traffic to that pod as a part of the service. service being the front end. Now I have a handy tool here. And if we had the service here,
Careful.
we had service here. All this the
That's
service,
better.
which acts as a load balancer. And we had some pods. Yes.
Wow. That service is getting a lot of traffic.
Well, it's DoorDash, so I'm like, it must be
That's fair.
tons of them. And all of these are good. Let me you get it. And then the readiness probe. Oh, can I do color? Yeah. Readiness says no. It's not spinning up new pods for these unready ones. It's just sending that workload to the ones that aren't yet dead, the ones that aren't yet tipping over. And so they were having a cascading failure start to happen, where it's like pretty soon you're going to get down to not many. You're at some tipping point. Not good. That's kind of how I interpret his diagnosis here. That's what they were witnessing.
Yeah, for sure. And, once you start hitting limits, the CPU is going to be, what's the word? I don't want to say
Throttled?
limited again. Throttled. Thank you.
It's throttled. Yeah. To mitigate the initial impact, we disabled the readiness checks on the pods, and service functionality was restored.
I can totally relate to that. It sounds so bad, though. It's so funny. You're like, yeah, no, you want it. You talk so much about the importance of a health checks or readiness checks. You talk about it, and the second it's preventing you from doing something, you're like, yep, get rid of them.
They're like, yeah, we're good. Keep sending it.
It's so funny.
Meanwhile, there's there's some fire going on back here. Everything's like, it's fine. Everything's fine here. Don't worry about it. All right, you take this one.
Okay. Understanding what failed. After the service was back to serving traffic normally, we had the opportunity to look into exactly what happened and what action items needed to be completed to avoid the problem in the future. Really? Wow. See, if they actually did that and they didn't just move on from it without kudos to them. Typically, when dealing with an outage of this nature, yeah, it's very good. I just feel like so many times something breaks, you fix it in the moment, problem goes away, and then you just never go and actually fix the problem. You know what I mean? Anyways, typically when dealing with an outage of this nature, it's important to look at metrics, traces, and logs. In this section, we'll outline our examination of each of these. Okay. So, looking at metrics to narrow down the search, generally the first place we look during an outage is our metrics. Metrics tend to provide the data on what is failing and what amount. For example, a particular endpoint is returning 503 error codes and is doing so 90% of the time. For this particular outage, our metrics indicated only an overall increase in latency on all endpoints, and the failing of a Kubernetes readiness check, which didn't narrow it down to a particular failure. Given that the metrics were not providing much insight, the next step was to take a look at the traces. Okay. Using traces to track down individual application requests. After narrowing down the failure to a particular endpoint or determining that the metrics were not helpful, the next step is to look into the traces. Traces provide in-depth information on what functions were executed during a single request. In comparison, checking logs is often more difficult because they can be poorly formatted and it can be very challenging to find issues without knowing exactly what to look for. Being a web service developer for a long time, we reached a point that I felt was a maturity thing. I really liked it, where we started logging specific information on each request for like debugging purposes. So we would like put little key data points in our logs. Nothing like that would like violate, HIPAA or anything like that. But it gave us ways to know like, oh, they were calling this particular thing for this reason. It was really nice. So, I mean, logging is as good as you make it, is my point. To analyze our Black Friday incident further, we looked at our tracing data. What we found was that health check endpoints were excluded from the reporting tracing data. This meant that the tracing data was not going to help us. Okay, so now it's time to go to the logs. All right, looking at the logs, since we were not able to find the cause of the health check failures in the metrics or the tracing data, we turned our attention to the logs. From looking at the traces, we know that health check endpoints were also ignored from application logs, making them less useful in this case. However, we also had logs from our ePBF agent. I don't know. eBPF. I mean, they put it in there like we're supposed to know what that is. So maybe it's an industry standard thing that we've just never come across.
They explain it in the next sentence. Keep going.
Oh.
Keep going.
A piece of software, not next sentence, it's the same sentence. A piece of software that runs adjacent to all our services and collects data on all TCP, UDP, and DNS requests performed by the service.
What? Zach, explain while I look it up. Zach seems to know everything.
Zach's a pro. Look at little B. Oh my god, I've seen this somewhere before. Did I write this down at KubeCon last year?
I don't know.
I swear to God, I've come across this before. By the 12.
Odin's beard. Okay. eBPF. Understood. Low-level stuff. Kernel runtime.
I like it.
Good stuff.
Strong move using yellow as your main marketing color.
Power play.
Yeah. Okay, so it's tracking all the networking traffic, which is awesome. And honestly, we should write that down. From these, we found a latency increase towards one of our Redis servers and a drop in request volume towards it when we disabled readiness checks. What was important, however, was that the latency increase on the given Redis server was on a legacy path. Hold on. That the latency increase on the given Redis was on a legacy path to be removed and should not have impacted our application. Nevertheless, it turns out the health check endpoint/path used in our readiness check was a default health check provided by the Spring Boot framework. Holla. The provided default health check endpoint performed various different configurable smaller health checks enabled by default, one of them being Redis. Zach says, oof, this makes me rethink the whole out-of-the-box nature of the Kubernetes stuff provided by Spring Boot. Yeah, it does. But at the same time, it's also good. They add all that stuff in by default because it can be very helpful. But in their case, it sounds like the Spring Boot built-in health check was doing some extra fancy checks for Redis. At least this is how I'm reading it, is that it has some extra smartness built into it specific to Redis because it's a very popular thing to use. And they're trying to do you a favor. But it sounds like they were doing something not standard with Redis and were unaware of that functionality. So when it went to check that extra health thing, it was getting not what it wanted.
Yeah. I mean, I love that I think this is a great story because this happens to everybody. Not everyone reads the fine print of the manual. I mean, and find me anybody that goes through every piece of configuration provided by Spring Boot. Like, it's a good tale to tell because you will definitely, the devil is in the details down here, and everybody's setup is a little bit different, it seems. but how many times, I guess I can't really think of a time when we were burned by defaults, but I guarantee you it's happened a billion times. And then you tune it and you move on.
See, yeah, that's just,
right?
There's so many things. You can't possibly know everything. And I really don't like operating in a state of like fear or overly cautious. Like, you got to be cautious. You got to do your due diligence, but you shouldn't operate so much in that area that it prevents you from moving forward.
Yeah. Yeah. Oh, I'm there. I've been right there, because you know me, I am definitely on the, if there was a caution meter, I'm in the red. I'm pegged in the red in terms of be cautious, which is, something I'm aware of. And too much of that can be a problem. Don't move anywhere.
And we talk about this all the time, and I'm going to say again, is that you're in the red, I'm in the green, and I think we balance each other out. I push you. I push you when you need to be pushed, and you pump the brakes when I need to slow down.
It's fun. So I think this is a great anecdote of them to share. Pretty interesting. Let's see. Is there anything good? After determining the hypothesized origin of failure, the theory must be confirmed. Must do science. It's good to hear them. I wouldn't think that they're not going to tell us this whole story and not tell us that they used the scientific method to prove that they were right or whatever. To test our theory, we use chaos engineering, which allows injection of failure into various aspects.
I would love an opportunity to do that.
Oh my gosh, I know. We have used Litmus Chaos, an open source chaos engineering platform that enables the injection of various failures through targeted experiments. Really? Huh.
I haven't heard of this one. And is it a part of the CNCF?
It's an incubator.
Wow. How have I not heard?
It's new.
I guess I haven't been keeping an eye on their incubations, but...
Core DNS. Generic all experiments. Kafka, VMware. Stress tests. Disk fill. Oh my god. Keep this off of the lab, please. Don't need disk fill problems. Kubectl apply really cool. And then let her rip.
I have
we're not doing this on stream. Gosh.
I have an idea for an app, and I'm very excited about it right now.
Oh god.
I'm not going to share it on the stream, though. Zach said, this is a big problem with public cloud docs for those example access policies that are way too open in my experience.
Which is a problem. The back to this, where they were like, yeah, we didn't read the defaults. Is that what you mean? Or are you talking about chaos engineering?
No, it was he posted that before when we were talking about
Gotcha.
Getting burned by default.
Yeah. 100%. 100%.
Pika.
It is a massive problem. What do you do? This might be fun to blow up a cluster. You just
I'm
install.
open to
it. Yeah. Maybe if we carve off some of it, we could try and burn part of it to the ground and see what happens.
I mean,
I don't know. We can look into that.
If it's for a stream, we could just stand up a GKE cluster real quick. We have the work center.
That's true.
Instead
as
of
it doesn't peg CPU and charge us $1 billion.
It wouldn't. No, you're good.
Good point, though. In order to proactively find failures to test our theory, we use chaos engineering. So wait a minute.
We configured an experiment called pod network latency, which added a 1 second latency to all calls to the Redis server, previously identified as a source of health check failures. 1 second was chosen because our readiness check timeout was also set to the same value. With the experiment enabled, we saw readiness checks start to fail in a similar manner as during the outage. I want to know what they did to fix it.
What? Oh. Oh, wait, there's a video on this. There's T-Mux. We've got to try this. This could be amazingly useful. And by could be, I mean, obviously it is. Okay.
Once all the sources of failures had been found and confirmed, it's important to create tickets and document all action items to avoid similar problems in the future. In our case, we first worked on configuring the health endpoint provided by Spring Boot so that it only performed checks on relevant dependencies. Then
we tuned it.
Then we documented the findings and proactively reached out to every team/service using Spring Boot to help mitigate similar issues. Additionally, we have also started an initiative to document behaviors of various Kubernetes health checks and share this knowledge across the organization. So, right. I mean, This really goes back to the first thing we talked about before we even read the article. Where I said, like, you can use the defaults from Spring Boot, but you can also extend them to check downstream dependencies and do things like that. I wasn't aware. I wasn't aware that it had a whole bunch of built-in smarts for different things. It doesn't surprise me, because Spring Boot is just jam-packed full of little knickknacks, but very cool. You know, I'm sorry. This whole, like, working in the DevOps space for as long as we have now, you have to know everything. I mean, you have to have a little bit of experience in, like, every aspect of IT. Like, this type of stuff, you have to understand the frameworks and kind of what they mean, and yeah, the T-shaped engineer for sure. But it's just so interesting because, like, you know, when we get calls from people, it could be, hey, my ingress is having issues, or I'm having a cert issue, or, you know, in this case, you know, my health check's failing. Why? And then you have to dig into the code and you have to help them with, if it's, you know, Java in a lot of cases, you have to understand Maven and how builds are happening, or Gradle, or, you know, and then you have to know how to write Jenkins code. You have to understand Git really deeply. And then on the other side, you're standing up Kubernetes and stuff, but you also have to be able to know what a subnet is, and set up your CIDR ranges, and know how to set up networking equipment and configure OSs. And like, you literally just have to know the whole stack. I don't know. I don't know where I'm going with that. It's just, I've been feeling that more and more lately. And I just feel like it's a big barrier to entry. It's something that you really, because when I got into DevOps, I'm sorry, I'm just, if you don't mind, I'm going to do an old man dialogue.
I mean, it's our podcast. We can do what we want.
No, so I approached DevOps from Java web service development. I mean, up to that point, I was just living in the development space. I did Android app design. I did a little bit of iOS. I played around with some HTML, CSS, but mostly I was a Java Spring developer doing web services. But from there, you know, you learn about like Swagger and Open API, that type of stuff. And, you know, that leads into, SOA architecture. So you learn about, versioning your APIs, what's the difference between REST and SOAP contracts, all that kind of stuff, doing some XML transformations, whatever. So you're in that space, and then you're like, okay, well, now you're starting to fall into this Kubernetes stuff, and you're like, okay, well, I'm going to learn containers so I can build my stuff locally. And then you move to Kubernetes and you find out about health checks, and then because you're in Kubernetes, you find out about all the features in Spring. that's how I got into this space. But then when I fully transitioned to being a Kubernetes engineer, that's when I start learning about all of the infrastructure stuff and storage and networking and just all these things that I just always took for granted being on the application side. Learning about DNS at a pretty deep level. Certs. I never understood certs until now. And it's all stuff I've picked up on the job. And I was kind of reflecting recently that, especially with a lot of the stuff we've been doing lately with our cluster, and I've been doing some networking stuff here at home, and I've just come so far in my knowledge that I think I take it for granted. And I just don't know how you can tell somebody, get a job as a DevOps engineer. I have no idea how you could tell somebody to do that. If your daughter, I think she'd probably do great in the IT space. But how do you train somebody brand new to the field? I don't know.
Internships. I think internships are maybe the only way to just start in there. How else do you just get in? I don't know. Yeah. You'd have to show a lot of, some people are just really smart and actually have good foundation in a lot of those tools by the time they come out of college, because they've been doing it for years already. Some people, but I don't think that's most people. To your point. Yeah,
I don't know.
It's and on the flip side, when we interact with people that took the opposite track into DevOps, and it's really hard. It's really hard. Because the starting point of the tech tree, it's a lot like it's a lot like a video game, but where you start from, and then you have shared, eventually you get these shared pieces of knowledge, and it's
that's the stuff that still blows my mind. Our one of our buddies who's the Linux admin, at least and when he's doing stuff like storage, when a certain amount is full, and then he goes in and deletes some, I forget what he calls them. What are they called? Not indices. They're
inodes.
Inodes. Yeah, I still honestly don't know what an inode is. But he's just you just got to do blah 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 to the inode, and I'm like, okay, sounds good. And he's just okay.
Yep, that's what learning feels like. Zach, it's definitely a challenge for places that have a hard split between their ops and dev. Definitely, ops folks need to learn code and how to use Git. Yeah, please, I think more ops people are learning Git out the gate, and devs need to learn a lot of networking, compute management. Yeah. And I think, we nailed it when we were implementing microservices, so a Kubernetes implementation, and we had most of the energy coming from just like Makita's track, the application track, and then we just kind of pulled in the Kubernetes API and just made it happen. And our ops people just kind of propped it up and nailed it. And we just kind of worked together and built a product on it. If you're coming from the other way and you have your ops people pushing, hey, here's the platform, and the dev teams are going cool. I think it works better dev and then ops bolsters servers, or bolsters infra, as opposed to the other way around. I think it works better that way because it's way easier to, I won't even say way easier. It seems less complicated, I don't mean to take anything away, to deal with infrastructure than to deal with application architecture. I feel like if you can get application architecture right, the rest, you got to mold it. But you can get that. You can just go to GKE and just try some things until you get the infra right. But if you write your code, if your code's crap, or if it's not tuned to be cloud native, man, I think you're screwed. I think it's tough. way harder than it needs to be. There's my rant.
Yeah. I don't know. You just triggered a thought in my mind, but I think it's a bunny hole thought. It's just the KubeVirt being able to run legacy VMs on Kubernetes. I don't know. I almost wanted to. I want to do a stream about that, I think. Because you were just talking about, if you're not willing to update your legacy application for the new platform, good luck to you. I 100% agree if you want to take advantage of all that stuff. But a KubeVirt, the way I've been kind of like thinking about it and hearing about it is like it's like kind of like it can be a stopgap. It's not by any means something you should like run long term, but it can be used as a way to like migrate these legacy applications onto Kubernetes while you're working to update them to a cloud native architecture. But I don't know. Yeah. It's curious.
All right, let's plow ahead. Common health check pitfalls. This is good stuff. Based on our findings, we wanted to share what we think are the common pitfalls. A pitfall is a lack of understanding of what different Kubernetes probes do. Yes. Pitfall: using third-party provided health check endpoints with no knowledge. Correct. You got to read the docs. Disabled observability around aspects of health checks included. This is a good one. These other ones seem pretty obvious, but this is a thing. Like when you're troubleshooting and you don't have everything, like if you remove or if you filter out some pods from your log indexes and you're not seeing the whole picture, but you think you are, same idea.
We do that, right?
That's why I bring it up. It's not good. I don't like it. It's a big risk. It's a risk and it's a pitfall, I think. In the same way
just to save space. That's the only reason they did that. They what is it called? When the log aggregator scrapes for the logs, you can have like a little Man, my brain's not working. It's the end of the day. But you can basically say, hey, ignore any lines that match this regex pattern. And the only reason you should do that is, the only reason you would do that is to save space, right?
You would do that if it was literal garbage. But I think the definition of literal garbage, I think, probably evolved. I think. But agree. This is a really good nugget to take away. As is this. Don't trust the defaults, or think about them. Think about any area you could be taking defaults, which is what ultimately they ended up doing. Lessons learned. Gaps in knowledge. Recommended steps. This is nice, actionable. Saying the same thing. Understand different applications of various Kubernetes probes. Ensure the entire department is aware of these use cases. If he can tell me how to do this, how to ensure the entire department is aware of anything, that'd be nice. Could you solve that problem for me? But this would be good if everybody was aware of that. Sorry, that's a tough ask in a lot of orgs. Verify the applications and options regarding third-party health check endpoints. Consider disabling certain features. Yeah. Instead of taking all the defaults. Yeah. Treat endpoints as tier 0 by instrumenting them with various observability methods and ensuring they are not ignored. That's a good lessons learned. If health checks are providing too much data, this is exactly what you just said. Consider sampling them maybe, or reducing the volume. Yeah. Better to have something there so that you've got something that's alive, or something that's living in your infrastructure, than not at all, because then it's off your radar. And finally, having a health check depend on a back-end dependency can be problematic. And Makita mentioned this earlier, because there are pros and cons to this. As an outage within your dependency can cause you to have an outage as Kubernetes restarts your containers. Yes, cascading failure.
Because we talked about this before. Like, if you, like, Man, I don't even know how to start this topic. Basically, a web service can have multiple operations, right? Multiple endpoints. And you shouldn't base like if one endpoint doesn't hit a database and another one does, you probably shouldn't make the entire pod's health check dependent on that database being up, because then you're going to take down that other operation, which is actually perfectly fine, which then goes to that whole concept of one endpoint, one service type idea, which I also kind of don't like, because now you just have a ton of different compiled code, which then leads you to Lambda type stuff, serverless stuff, which makes it more approachable. I don't know.
Anyway,
I feel like I'm in a Dilbert comic right now.
We definitely live in a Dilbert comic. This is a very nice little article, and appreciate Andres and DoorDash people sharing. I think it's a pretty nice little write-up of something everybody could learn something from. We're not going to talk about the ultimate guide to Kubernetes services. Number one, there's not enough drawings, and I was going to have to draw it. This isn't bad. You could check it out.
Yeah, we took the entire hour to talk through that one thing, but I actually thought it was really, really good.
Oh, that's it was a nice little article. And, check out the KubeWeekly. It's got good stuff. Good stuff. Usually there's more in here than I have time to devote to. Especially, they have a lot of good resources like, hey, check out this website for where you can find all the up-to-date Helm charts that people are using. I'm like, oh man, I had that stored away for a rainy day. Did you post it? All right.
I did. I put it in the chat.
All right. Cool.
Yeah. No, I think this is good. I don't think we have enough time to go on to another topic, so.
No.
I actually had a lot of fun talking about this, though.
Yeah, that's a good one.
Kind of touched on a lot of areas, actually.
Some good red meat for us. I mean, this is right in the pocket of... These are real problems, and I like knowing that other people have them, not just us.
Out of curiosity, Zach, I think you're the only one here, which we are fine with. It's a very niche topic. Do you like this type of content, or do you prefer the more hands-on stuff where we, experiment and code and stuff, or are they both good? Just out of curiosity. Because I had a good time talking about this, honestly. So I'm like, maybe we do this a little bit more often than we do today.
You can always follow up in the Discord. We've had some good people. We've had some good recommendations on other topics in the Discord, but yeah, they're usually technical. Usually, people want to talk about solving their little niche problems and stuff.
Yeah, we got a comment about the HA proxy stuff.
Yeah,
before.
Yeah, reading about other places' experiences, as you find problems are not as unique as they seem. Absolutely, that is the benefit of going to the conferences, and usually you just hear a bunch of people that have the same problem as you do, and that feels really good. I think that's the best use of a conference, is to have some camaraderie around those.
Do you remember that?
Those
where were we? It was you, me, and Sam. What KubeCon
was it at? Was it at this one?
No, this was the most recent one, wasn't it?
Was it in Los Angeles?
I don't know. By the way, this matching shirt thing was completely an accident.
This was on accident.
No, it was not Los Angeles. It was the one. It was just the three of us. Oh, Seattle. We were in Seattle, and was that the one where Red Hat had their thing at the beginning? Like, we went 2 days early and went to
yeah,
OpenCon or whatever it was called, OpenShift Con.
Yep, Red Hat Days or something, whatever it was.
That, I think it was one day, and that one day smaller conference before KubeCon was the highlight. It was so much better than KubeCon itself, because like half of the thing was them bringing in their clients, big clients. Like, I think they had like Ford there, and they had like HP and like these big clients, and they presented white papers just like what we just talked about, and it was so good, and I loved it. And then they had really, really good food.
Yeah. And we talked to Clayton Coleman.
Clayton, I meant to bring him up today.
Still hold a man crush for Clayton.
He's just a nice guy. That's why I like him. He talking to him, he he's the big guy. At least he used to be. I think he stepped down since then, but he was the guy that merged PRs into Kubernetes mainstream. He was the final sign off. He was the top architect, and he works for Red Hat. And yeah, we saw him, and we, sheepishly approached him. And he was so nice. He literally just said goodbye to who he's currently talking to and came over and just gave us 100% of his attention. And we talked to him about the difference between a deployment and a deployment set, because back then OpenShift had a different type of deployment object to support extra functionality that that Kubernetes mainstream didn't want to pull in. And I was asking him, should we be using deployment or deployment set? Because if we use deployment set, we're kind of locked in to OpenShift. But if we use deployment, it still works in OpenShift, but we can, we're not locked in, blah, blah, blah. And he was just so nice and just super chill. He wasn't a businessman with it. He wasn't trying to talk us into using Red Hat stuff, because he managed Kubernetes. I don't know. I just liked him a lot. He was just so nice.
Deployment config.
Deployment config, correct. Sorry.
Yeah. And
It's
then
been a
I
long
think
time.
they ultimately retired that, right?
Oh, you're in 3.11 right now. Can you click the drop down for 4 or 11? Page is gone.
Yeah, I don't think it's in 4. Ooh.
Well, maybe it is.
It still is. Compatibility level stable with major release minimum. All right, it's still there. If I'm reading their documentation correctly, deployment config is still there.
Yeah, Zach, OpenShift is very good. It's very, very good. It's the Corvette of Kubernetes. It's expensive, which is why I don't use it. And I know Kubernetes really well, so I would pick something like Rancher probably, because I can support it and install all the tools myself. But literally OpenShift comes with everything. Literally everything. It comes with Argo CD pre-installed, Rook pre-installed, Cert Manager pre-installed, everything. It's a push button start, and it is beautiful, rock solid, but you pay for it. But everything's supported out of the box, just works. They even control everything down to the OS, and the OS is based on Core OS, so all it can do is run containers, and it's been designed to run only OpenShift and it auto updates for you. And it has even with bare metal, it has cluster auto scaling built in, so as long as you have some warm nodes sitting there with the storage ready to be mounted, you could just spin up and spin down cluster nodes at will. Even bare metal. Don't even get me started if it's in a virtualized environment. Really good.
All right.
Whew. Okay, I need more caffeine. I will talk to you tomorrow, Dan, and everyone who's on the stream. Zach, have a wonderful afternoon. Thank you for joining us today on the Cloud Native Coffee Hour. We'll be back. We might not be back next week, unless you can wrangle one of our other guys to join you, because I'm on vacation and Sam is on vacation.
It might be a surprise crew next week, so or it's going to be a solo act maybe. We'll see. We'll find out next week on the Cloud Native Coffee Hour. Thank you for coming.